Welcome to EE 380 for April 20th, 2022. My name's Dennis Allison. I curate the course, and today I happen to be the lecturer as well. And we're going to try to explain why that's happened. I think this is a difficult time for everybody. I've had, I have been doing the 380 course for quite a long time. I think something like 40 plus years. And it's usually very easy to find speakers who are willing to come and talk. In fact, we've had people fly halfway around the world and spend a whole week traveling so they could come and give a 1-hour talk here in a colloquium. Since the beginning of the pandemic, or maybe slightly before, that's really changed. People are doing things differently than they have been. And I found that people they're just not quite as aware of what's going on. Now, this is the commercial community and the professional computing community as well, and the research community, as well as the student community, that we generally few undergraduate or graduate master's level people who want to give talks. Mostly it's PhD candidates and people doing research. But the thirst for publicizing oneself on the web and so forth partially has gone away because anybody can make a video, or it's also gone away because people are trying to be more private. Now, as a curator, my mode of operation is to look at what's going on, pick an interesting topic, find out who knows about it nearby and far away, talk to them over the internet, and maybe a year or two later, get a speaker to come and talk. And that's worked pretty well. Of late, not so well. People don't answer. They don't answer their emails. In fact, most people don't read their emails. And of course, we have Twitter, which is write only. And no one ever reads their incoming Twitters, do they? Anybody have that as an experience? How many of you use Twitter? That's even a better thing. Yeah, okay. In any case, I agree. It's there are, for a messaging app, it's about second to the bottom. I think LinkedIn has won the bottom rank. On the other hand, LinkedIn has better access to addresses. If you need to contact, probably the best way to do it is to, in any case, let's see, where was I? I was talking about the lack of accessibility. People don't put their addresses on the internet anymore. They don't use emails. They try to hide emails. Companies don't have their physical address on the internet, nor do they sometimes even put their web address on the internet. It's sort of as if they're trying to hide out. And when you're looking to find what people are doing, and not without any real malice, want to get them to come and talk about it, it's hard to find the people and get them to say yes, they'll come. This has led to an occasional problem for us, or for me, in that the period of time that you can book people into the this particular course requires a substantial lead time, and finding a speaker late in the time period is extremely difficult. So if you don't get speakers lined up and they all don't agree and no one changes their mind or wants to change their schedule or needs some special thing, it goes very smoothly. And as a result, half the time the quarter devolves into chaos, and we reorganize everything every few minutes, it seems like. So what happened this time was that the planned speaker was called away to do something more important than this, and so he's unavailable, and finding other people to step in was, in this case, possible. Worked fine in a sense, though, in the sense that I got to think about this, and now I can come back and do this. But so we have the issue of, are people going to be public people expressing their views in public, or are they wanting to hide out and just be very quiet in the back room? The same thing is true about topics, by the way. There are topics that people will not touch. And there are important topics that we manage to critically avoid. One of them being, we'll go through several. One of them being vaccinations. It's very difficult to get in willing to talk about the COVID vaccines and whether they're being applied right, and what the actual numbers involved are, and so forth. What this particular pandemic has trained me to do is to worry a great deal about the accuracy of the public health people and their willingness to produce and describe detail numbers that are not particularly pleasant. But that's been a very interesting thing. I think it falls into the same category as the names thing. There are lots of other areas that things are not quite right in my taste. We have lots of people who are putting out false information of some sort onto the internet, and the most interesting of them are remarkably credible. They use long Latin and Greek rooted words which have vaguely medical sounding pronunciations, and create their own meaning for these terms, or they take standard things and can make them not what they really are, but move their scope into a different area, and produce a story credible to non-speakers, non-scientists, but frightening and disturbing and creating disruption, I think. The anti-vax people are, I think, very bad for the sciences, because it really has helped destroy belief in science. In fact, science is not faring very well, and I don't think it's necessarily the scientists' fault. Scientists tend to be very factual in their descriptions of things, and they don't really try to sell their theories in general. and that I think is a failure. But it's sort of part of the times. Likewise, we don't have anybody who's willing to talk about the global warming stuff. There's more people here at Stanford, I think, that do that than in most areas. But the global warming thing and our you know, we're toast, or literally toast. It's not a good situation. It's not getting better, it's getting worse. And relatively few people are willing to look at it. I mean, how many of you believe that global warming is going to have a major impact on your life in the next 10 years? Next 5 years? Okay, so you think you have 5 years. Probably not true. It's probably already here. And it's only been a topic of study and conversation and concern by the geophysicists for the last 45 years or so. And yet, now that people acknowledge at least that it's a major problem, has anything been done substantively to try to correct it? You wave your hand. Is it something which you could tell me what it is?
I mean, we closed that hole in the ozone layer. That was pretty cool. It's related to global warming.
Pardon?
It's related to global warming.
It is related somewhat to global warming. Yeah, I made one of the first ones, the holes. You know, project which funded by the Air Force, where we made a hole in the ionosphere, and it got as big as all outdoors. Literally, it was quite interesting, and it only took a few pounds of a sulfur hexafluoride. It inserted at the right point, which is several hundred miles up. But the chemicals which we're using now in replace of the chlorofluorohydrocarbons are not as bad, but they're not very good. And so we are still pumping out very large quantities of stuff which produces destruction of the ozone layer in the ionosphere. If you lived in Australia or visit, you would see that the Daily News would have a sunblock requirement as to how much sunblock you should put on, because they sort of keep track of that and the ozone layer above and decide that when things are going to be critical. But that's another thing. So, well, you can continue on with other examples of places where we have not really, as a collective community, managed to get any sort of action performed. Yes, go ahead.
Well, I guess,
That's right. And in fact, that's the Bitcoin and blockchain ideas are not really energy conservative, and tremendous amounts of energy are being used today to manage the Bitcoin blockchain or such, and probably a bad idea to use it much at all. And the reason, of course, is inherent in one of the goals of the Bitcoin idea. That is you want multiple places that you can take a piece of information and stick it on a timeline and know that it occurred between point A and point B. And you want to be able to do that from any site you are, and there are going to be lots of people monitoring that. And so it all has to happen in a fixed period of time. And now you've just created what's pretty much guaranteed to be a very difficult problem to solve. Now, the fact that most applications that use Bitcoin don't, the fact that it's distributed and has multiple application points is usually sort of ignored. But many of the things that people use Bitcoin for are essentially could be accomplished with a fairly reliable set of single entry file systems and much more energy efficient. There's a CACM article by Maurice Hurley on the Bitcoin blockchain and what needs to be done to fix it, and it's worth digging out. How many of you read CACM? How many of you read computer? Byte? Wired? Yeah, occasionally wired. Okay, so that's interesting for me because I always found that the popular literatures were pretty interesting, and the magazines like CACM were really helpful. CACM has been, well, I would say dumbed down. That is because the computing community has grown very large, and most of the people don't have a great deal of mathematics, and in fact, not a great deal necessarily of programming capability at this point. The content of the CACM doesn't really step into anything that's really very complicated. And you have to go to one of the other ACM publications like the journal or one of the SIG publications to find things that are really new and interesting and solutions to problems which are hard. So, and one of the things I'm always, so in any case, I'm painting a picture of how strange things really are. That is, a lot of the protocols that we developed for maintaining science and the reputations of science as a safe and suitably reliable source have been abrogated. Part of this seems to be due to the fact that things are kind of difficult to understand. But I don't think science per se is necessarily hard to understand. What is hard to understand is why people are always trying to, when they present things in a popular way, they always try to provide 2 points of view, the one and the other. And so you get situations like the Earth is round or the Earth is flat, and the people who believe it's flat get the same amount of storage presentation space as the one purchased for the round. That's, I think, difficult if you're not really sure whether the world is round or flat, and because it tends to give you the wrong idea. I think that's a big issue. The fact the world is not fixing some of the known problems is I think a very, very difficult thing. And I think that means that we probably ought to be out there trying to change the way that the world views science and engineering, and the way the world views solving these sorts of problems. Maybe I'm naive, but I think that's important. In California, we have, going back to other sorts of problem areas, in California, we have massive forest fires. It happens in other parts of the world as well. But we don't really pull out all stops and try to stop the forest fire and minimize the amount of carbon dioxide that gets generated. I'm not really certain why the government does not choose to try to do something like that, because it will, in the long run, help us. We had a talk a couple of years ago. Oh, I guess it's last year, from David Henkel Wallace about his startup, Blue Origin. Well, I can't remember. I think it's Blue Origin or something like this. In any case, you can find it in our listing on YouTube. And it's a very clever thing. He decided that he had found a loophole, and he could actually easily build the device at a relatively low cost, which would help the global warming situation. So he did. He's in the midst of doing this. It's a very clever idea. He's burning methane, converting it to carbon dioxide. Now, it turns out methane is a much better greenhouse gas than carbon dioxide. It also doesn't last as long in the atmosphere. So methane is about a 100-year persistence as opposed to a 1,000-year persistence or something like that for CO2. And most of the methane that's produced and released into the air comes from shipping, it turns out. We ignored the land masses and concentrated only on on water-based systems. The reason being that water-based systems are controlled by international law, and the land-based systems are controlled by whoever happens to be running the countries at the time, and it makes for much more difficult dealing. So basically, he has a catalyst that's relatively inexpensive iron salt that, if you put it in the smokestack of a container ship as an aerosol, it's hot, goes up into the troposphere, part of the atmosphere that's dense and close, and it will, with using sunlight, convert any methane that's floating around into carbon dioxide and water. And to sell his idea to people who were watching what's going on, he did some simulations using the atmospheric modeling tools that are readily available these days, and demonstrated that this would probably cause, if applied for several years, drops of up to a half a degree of centigrade on global warming. And this whole thing could be done for reasonably small amount of money. Now, what reasonably small amounts of money is something that has global reach is complicated, but it's not that bad. So it's interesting to see what he's doing, and yet I would have thought that the world would have been beating a path to his door to try to get this started and be put out and used as quickly as possible. And that has not yet happened. Maybe next year. So we have problems with the society, problems with sciences. We're in the midst of the beginnings of, I don't know, what's your belief? At the start of World War III. No comments. Not even from the audience out here. If you're going to comment, you can turn your voice on and say, "Did you think that we're at the beginning of World War III?" I read the New York Times this morning, and it's like things were not stable in the Ukraine, and so we have this proto-war that we're beginning to look at, and that war is being fought in a somewhat different way, and that's really actually quite interesting. Almost every country in the world has decided that it's a bad idea to fight for Russia and Ukraine to fight a war. And so that they have been working to sort of isolate Russia from the rest of the world, which turns out to be a very difficult thing to do. Paul Vixie, who's an expert in the in internet DNS, did a study and showed that taking the .ru domain out of the mix of domains was a very, very difficult job. And in fact, he found out all sorts of interesting things he didn't know. For example, the .ru routing for lots of things went through the Ukraine, and the Ukrainian stuff goes through Russia. And so it's an interesting problem when you decide that what you want to do is to isolate a particular country economically and culturally. But our astronauts back from the International Space Station on a Soyuz return vehicle this couple of weeks ago. But if there was an all-out war, it's not clear that that's what happened. And then the Russians are claiming to bond with China, and then they will use hypersonic delivery vehicles and atomic weapons and such like that if they don't get their way in the Ukraine. Whether they will or not is an open question, and I don't know how we know about that. Another place that I think, activism is possibly important. The the economies of economics is fairly interesting thing to take a look at. U.S. companies are many of them have operations in Russia, and it's a difficult thing to watch what's going on. You know, for example, Oracle has a development center in St. Petersburg. Always order 1,000 people. Does Oracle system construction and maintenance for companies throughout Europe, and so has access to lots of the Oracle software and so forth. Oracle's does well in Russia, and now they're thinking of having to close that down and to turn off the work that's being done. But they have, of course, many clients in Russia, and Oracle is very successful in what they do. And, you know, it's not clear what level of support Oracle is going to need to provide to keep its customer base in Russia happy in the midst of the ongoing war. Presumably, I don't know. It depends a lot on what contracts that Oracle has with Russian entities that are enforceable in Russia. And, you know, I have found nobody who seems to know. But it's an interesting issue because it gets replicated 1,000 times or more in other places in the Russian economy. The people who study the distribution of food, which have said that the Ukrainian-Russian war is going to kill a number of people in India, a large number. Why? Because Ukraine is supplies much of the wheat that is eaten in India. And if Ukraine does not produce wheat, it's not clear that there's enough support around to actually do that and to support the needs of India, independent of whether there's money. It's all very very complicated, and when it requires technical knowledge of in order to make reasonable decisions, we don't have people who are skilled at doing evaluation that are available. We have, you know, our U.S. government intelligence people, and we have our sort of ragtag, uncoordinated collection of people who do analysis for and none of those seem to have a great deal of impact on U.S. policy. You know, that's an issue for me. So these sorts of things have really been a motivator for essentially doing independent research on what's going on. And by the way, the things I've said all come from very reliable sources, like somebody on the internet, some of which is clearly going to be wrong, and the little accuracy of news articles that are published, even when they should be very, very good, is not very high. So in addition to being confused by the actual situations, we can be confused by people trying to change our understanding of what's going on. Typically, you like to get 1, 2, or 3 or 4 sources from the same thing, and you oftentimes can get multiple sources, and the sources are in conflict. For example, Google released a version of the Google Maps for Russia, where Russian military targets were not fuzzed, and this was surprising for a number of people. And Google said, "No, we didn't do it now. We did it a long time ago." Other people say, "Well, it just appeared now," and so forth. And so you have many different stories about what the situation is, and it does not always compute. Then there's beginning to be a community of open source intelligence and analysts who are not attached to a nation state's intelligence organization, but who do analysis of data in various ways. And this is what I was hoping I would be able to have a speaker on, because I think it's very interesting that we've reached a point where the level of analysis that's needed to simply make sense out of the news that's in the various news feeds has gotten to the point that you need a separate, independent, and welcoming organization to do that. So we're actually moving right along here. The question is, what sort of things are you guys interested in? I mean, I'm interested in producing essentially journalistic level analysis, accurate and true, of many of these sorts of things. Because I think that's important for everybody to understand. Yeah. Yes.
I'd like to participate for a second or two.
Please do. I'm sorry.
I'm Scott here. I've known Dennis for a while now, from before COVID, when we had a face-to-face at Stanford. It was great. So nice to see you again, Dennis. And the one I remember was Michael P. Frank's lecture. I don't remember if you were there, but then we went and had Chinese dinner together and talked about what Mike was doing. So since that time, I actually started a new company called Earth ICT SPC. It's Earth Information Communication Technology Social Purpose Corporation for the Environment. It's a California new type of incorporation model. And so I'm working with the Sky 130, which is a free open shuttle that Skywater's running, and using that to put together some adiabatic computing projects. And the thing there is the UN is calling for the ITC sector to hit 1.5C by 2025 trajectory. And one way of doing that is, of course, is to get alternative energy like sun or wind to power all the communications ICT sector stuff. the other way, or a complementary way, is to get energy efficiency. And most of the community doesn't understand that, you know, the energy efficiency of computers is basically zero. All the energy in comes out as heat. So that's diabatic computing. So part of the effort is to communicate that there is an alternative way of doing things, and go through all that anyway. So I am just asking the community in terms of participation. I would love to, I'm working with NG Spice, so I'm right down there working on a circulatory high quality resonator power clock, and that's getting right down at it. And so if you got any electrical analog energy engineers out there, mostly we find people who understand quality factor in the RF area. You know, the RF people understand what quality factor is. So getting that into the clock and the digital computer is something to be doing. Anyway, that's all I got. And thank you very much, Dennis. It's great to see you again. And I love E380.
The URL will stick you on. I'll stick it up on the web with the talk.
Thank you very much. Yeah, I in the comments section or in the chat box, I've been sticking some things up, but I will send you some stuff. Thanks very much, Dennis.
Okay, great. Thank you. So that's sort of where it is, you know, and, you know, so you have lots of little people who are sort of operating as small entities, but we don't have any collective efforts. And that's a problem. So is this the sort of thing that interests you? It's always the question. If you wanted to spend time listening to talks about metamaterials and stuff at atomic scale or smaller, we can do that. But I think the immediate impact is a lot of these sort of semi-social things is where the problems really lie. We can make really great AI chips. In fact, there are a dozen of them that are sort of being described at Asilomar this week. They're amazing, and we get to build them in very small geometries, and they run very fast, and they don't consume all that much power anymore. We're going to have interesting computing devices in the next 20 years. You know, problem there. The manufacturing, the fabs are not really, there aren't as many of them as we need for what our desires are. And contrary to what people have in the news have been telling us, it takes a long time to make a fab of that quality. You know, the 3 nanometer or 2 nanometer nodes in a fab take a lot of time to qualify. And so you may have building built, but you can't populate it with the equipment you need for fabrication, or the equipment has not had enough time that the statistics are understood well enough to get the yields up. And it's going to be an interesting time. So anyhow, I'd be really interested in what your interests are, because I have slots to fill, and I have choices to make. Mine are that I'd like to see some change in the way that people think about science and engineering. I'd like to see more mathematics used. I'd like to see people understand that modeling actually works, and that you have to be careful how you do it. It takes some level of skill to do systems modeling, but it's perfectly rational way to approach things. And so the people who try to denigrate the UN climate reports really haven't read them, because they're very convincing. And in fact, if anything, you could argue that because they take so long to produce, what they're reporting is ancient history. Beyond that, I pretty much have said my piece. And thank you for being my audience.